So welcome back. I've started some shell code here. I've got a class that's named variables and data types. Remember, classes should start with a capital letter as their identifier. And then my main method, public static void main string args. Okay, your open and closed brackets here can be after the word args, or they can be before the word args. Okay, it makes no difference. It's going to compile either way. And the spacing, remember, outside of a string literal doesn't make any difference in Java. So you can have those spaces there or not there, right? However it is most readable for you is fine with me. It's not going to affect how the program compiles. Okay, so today we're going to look at variables and data types. And a variable is just a name for a data field. Now, before we can assign a variable or give it a value, we have to tell Java what type of data that variable is going to hold. Okay, so for instance, I might have a integer, and I want that integer variable name to be, well, X isn't a very good variable identifier. Let's say it's hours worked. Okay, so int hours worked, the variable identifier, its name is hours worked, and its data type is an integer. Okay, and that is going to create a location in memory, and the name of it is hours worked, and it'll hold only an integer. So I can assign, now that I've created that variable, I could assign it any integer I wanted. So hours worked equals 8 if I worked 8 hours that day. Okay, so now I can check that this is working by outputting that variable. So system out.println, and we're going to print the hours worked. So let's go ahead and compile. See if we need to do any debugging. There we go, operation complete. So it compiled, now we can run. And notice we told it to print hours worked, and we got an 8 reported to the console. So that 8 was assigned, that value, to the hours worked variable. Okay, if I was writing a program that calculated a person's pay, so maybe their hourly pay is $15.75 an hour. Well, the decimal is no longer an integer, so I can't declare it in an integer variable type. For decimal numbers, we usually use double. Okay, double meaning decimal. And we'll say that this is our hourly rate. Okay, so now I've created the variable. Its data type is a double, which is a decimal number. And now I can assign it a value. So hourly rate is $15.75. Okay, now in my system.out.println, I'm going to output what their pay is. So let's make a string literal. Your paycheck will be. Okay, and then remember from our last lesson, we can concatenate or join on number values to string literals in an output statement. Okay, since I'm going to do a math operation, I'm going to put parentheses around it so it calculates that answer and then concatenates it to the string literal at the front. And to calculate their paycheck, I'm going to take the hours worked, and I'm going to multiply that times the hourly rate. Okay, then I have to close the parentheses on the print line method, and then I'll need a semicolon for the end of that programming statement. So let's go ahead and compile, see if we need to do any debugging. Okay, now we're ready to run. And my paycheck will be $126. Okay. Some other variable types we could use. We could use a char. Okay, a char is a character. So char might be my first initial. So I can declare my variable type as a char and then say first initial equals, and then I'm going to put my character in a single quotation. So we'll put W for wolf. Okay, now let's change our output here. So system out print line first initial. Okay, we'll go ahead and compile. And then we'll run. And there's my first initial, right? Capital W. Okay, I can comment that one out. There we go. So the char will store just one character. It will not store any additional characters. If I want to store both of my initials, I would need to do a string. So since it's more than one character, I can declare my both initials as a string data type, and then both initials is equal to, and I use double quotes around my string literal. So the data type is a string, right? The variable identifier is the variable's name, both initials, and that string literal requires quotation marks as opposed to single quotes or apostrophes up there. So let's go ahead and output my both initials variable. And there's my initials. Okay, so now we've looked at variable declarations, right? That's where we declare the type and the name or the identifier for the variable. And we've looked at variable assignment statements, and that's where we assign a value to that variable. In Java, you can do declaration and assignment on the same line. So I could just say my hourly rate, which is declared as a double, is equal to $15.75 and have that all together on one line, right? And that would be fine. Okay, I can also have my identifiers be anything that I want within certain parameters. So for instance, this hourly rate is in something called camel case. Okay? In camel case, the first letter of each word after the first word, so each subsequent word is going to be a capital letter. Instead of using camel case, I could use an underscore. So I could say double hourly rate and use that underscore in order to make it a little bit more readable. but my variable has to begin, well, not has to, but should begin with a lowercase letter because we use capital letters to indicate class names. Variables should be lowercase letters. And it must start with either a letter, a $, or an underscore. Okay, so if I were, for example, to try to make this 2 hourly rate, okay, like if it was, say, double time on a holiday, right? When I try to compile, this is going to throw an error. There we go. And see, here's our description of the error. It says variables and data type error, semicolon, expected. And if you notice, right, the reason that it's expecting a semicolon is because of this problem right here. It sees the 2 and it thinks, oh wait, that must be like the end of a statement that they made. Maybe it should be on the next line. So when you're debugging, right, it's not always obvious from the description what the problem is, right? Adding a semicolon here would probably get rid of this error about the semicolon being expected, but it's not going to take care of the problem of this variable identifier, right? And the double wouldn't be assigned to any identifier then. So to avoid that happening, we have to not start our variable names with numbers. Okay, they should always be a letter or a $. Right? Your variable can start with a $, or it could start with an underscore. Okay. So for readability's sake, I usually just begin it with lowercase letter, and then I use camel case. But again, you can use that underscore to separate the words in the variable as opposed to using camel case. Okay, whatever's more readable for you. Okay, by convention, your variable identifiers, the names you choose for your variables, they should mean something. They should tell you something about the data that's being stored. So you want to avoid variables like x, right? If I say int x and x equals 8, that doesn't tell me anything about what that 8 represents. Is that 8 the number of cats in my house? Is that 8 the number of like teeth that I've lost? Is it the number of hours that I've worked? We don't know if it's just a letter representing it. Okay. Likewise, I would avoid things like HR, right? You might know that you intended HR to be your hourly rate, but you usually code on Teams, and your partner down the hall might not know what you meant by HR and assume that that's meaning hourly rate. So using the entire word hourly rate, that doesn't have any ambiguity, right? Anybody who's working on your coding team can read your code and understand exactly what that data 1575 represents in the context of this problem. Okay, now something else that is a no-no for variable identifiers, they can't have spaces. Okay, hourly rate has to be joined with an underscore, or it could be camel case, so that the first letter of the word is capitalized for every second, third, fourth word. But it can't have a space in between. Okay, that's going to throw an error again that Java isn't going to understand and won't be able to compile. So if we hit the compile button, there we go. So now we have another semicolon expected, right? And we can see that Java expects that semicolon to be here between double hourly and rate equals. And that makes a little bit more sense about why the debugger is suggesting that, because we could declare hourly as a double, and then we could assign rate to a value. That seems like it would make sense, but that's not what we're trying to do, right? What we're trying to do is declare one variable as a decimal type, a double, and assign it the value 1575. Okay, then the last thing that you need to be careful of with your variable identifiers is they have to be words that are not reserved words in Java. So for instance, say I wanted this to be the final score of a baseball game. So I might say int final, but notice when I type final, it turned purple. That means final is a reserved word or a keyword in the Java programming language, and it's off limits for variable types. Now I can avoid that by saying final and then score. Final score, right? Now notice that's black, it's not purple, so that's an acceptable variable identifier. Okay, so let's take a look at another type of data, and that would be the Boolean. So Boolean is a true or false data type. So if I had a Boolean that said graduated, okay, then I could say graduated, if I spelled it right, graduated equals true. Okay. In a math class, we would see graduated equals T, and we know T means true, but Java doesn't know what a capital T is. So instead of a capital T, we're going to use a word that Java recognizes, and that's true with a lowercase t, and see how it turned purple. So now we know that that's something that Java understands and can assign to our variable identifier graduated. Okay, same thing for false, right? Instead of using a capital F, I would say false, and that false turned purple, so now I know that that's been correctly identified as the way to mark that Boolean in the memory. Okay, so when I print system out print graduated, then we can see what Java outputs. Okay, and it returned to the console false, and that false is the value of the Boolean variable. It's not a string literal, right? It's not quotation marks around the word false. It's just returning the value of the Boolean. And there are lots of different data types. Let's take a look at those. Okay, so here are our different data types. We have primitive data types, which are not objects. Okay, primitive data types store numbers, numeric values. So a byte, B-Y-T-E, that's a signed integer. It can be positive or negative, between negative 128 to 127. And that takes up just 8 bits of memory. Okay, a short is a little larger than a byte. A short, also a signed integer. It's from negative 32,768 to positive 32,767, right? That takes twice as much memory, 16 bits to store instead of 8 bits. Int is the most common integer size that we use. Now that memory, computer memory is so inexpensive. There was a time a while ago where computer memory was precious and very, very expensive. And so you would only use or allocate as much memory space to store data as you absolutely had to, right? Now that memory is so abundant and inexpensive, we just tend to go right to integer, even though it's 32 bits, because it has a much, much larger range. So we're not likely to go beyond that range in our normal everyday applications. And then we can just default to that. Okay, float is a decimal, a floating point decimal, and a float, you have to put a little letter F after the value when you assign a float. A float is a decimal number that takes up 32 bits of size. Okay, a double is also a decimal number, and it's twice as much memory, right? 32 bits to 64 bits. But again, because memory is so abundant and inexpensive now, we tend to just use double all the time, and we don't worry about the float. Okay, so on the AP exam, you're only going to need to know int and double because they're the most commonly used now because they have the largest range, right? But they do also take up the largest amount of memory of those different data types. Okay, if you're in a programming situation where memory is scarce, you need to be careful about how you allocate memory. You can use a float, right? It's a smaller sized decimal, but you have to use that lowercase f when you assign it. For longs, right? Longs are bigger than ints. Okay, they're 64 bits. But you have to use a capital L after the value when you assign that long value, that signed integer, to the data type long. And because that's just an extra step that you have to worry about, that capital L, we tend to just use int because it's still a nice big range, but it doesn't require that extra step of putting a capital L at the end. Okay, so again, the AP exam, it's only going to look at int and double. It's not going to look at the byte, short, float, and long, but I want you to be aware that those different data types exist and why, right? The fact that their ranges are smaller and the memory amounts that are allocated are smaller in some instances than they are for a double and an int. Okay, the string data type is not a primitive data type because it's not storing a numeric value. It's an object data type. Okay, and we'll talk more about objects when we get to Unit 2. Boolean and char, character and the true-false variable types, those are primitive data types because they do store numeric values, right? In a Boolean, we type Boolean is true, Boolean is false, but what's being stored in the memory is actually a 0 or a 1. A 0 for false, a 1 for true. Okay, a char, a character, even though we type that in with single quotations and the actual value, it's storing it in memory as a Unicode character. So it has a numeric value that's being stored in the memory. So these are all primitive data types, numeric data types, including the char and the Boolean. Okay, so now let's talk about casting. So let's say we have a double, and remember a double is a decimal data type, and we're going to make that double hold a person's weight. Okay, and then we'll have, let's do an int, and that will be quantity. So actually, instead of a person's weight, why don't we do the weight of an item? So we'll call this on item weight. Okay, and then the item quantity will be an int. So if I wanted to assign item weight equals 10. Okay, so let's say I have 10 pounds, a 10-pound item. Then I'm going to print that variable. And let's take a look at what happens when we do that. Okay, so there's my item weight being output to the console, and even though I entered it as an integer 10, it's being output as 10.0. And that's because item weight was declared as a double, a decimal type. And it's always going to return a decimal whether you enter one there or not. So if my item weight was 10.5 pounds, right now when it outputs, that decimal will be 10.5 instead of 10.0. And there it is. Oh, wait, nope, that's the 10.0 from before. Boy, my Java is slow today. There it goes. Okay, so 10.5 got returned as the item weight. Now, if I wanted, let's say that this is total weight and then we had int quantity. Okay, so my item weight, one individual item is 10.5. Okay, let's say my quantity is 7. Okay, so I have 7 of this item. Now I'm going to output the item weight times, item weight times the quantity. So what I'm looking at here, I'll go ahead and run it since it's going so slow, but what I'm looking at here is going to be the product of a double for item weight and an integer for quantity. So when we multiply a double times an integer, if we look at our output, if it ever comes up, there it is, 73.5, right? It returned a double. So a double times an int is going to be a double. So what happens if I try to take that double, so total weight equals, and I'm going to make total weight be this product of item weight times quantity. Okay, and then I want to output the total weight. Okay, so I'm taking a double times an int, which is what we just saw, the output was a double. Will Java let me assign that then to a total weight variable, which is an int? So let's see if it will run. And we get an error. Okay, it says incompatible types, possible lossy conversion from double to int. What that lossy conversion means is we would have a loss in accuracy trying to take a double, a decimal value, and put it into an int. So Java will not allow us to do that just the way it is. Okay, so in order to get this to work, we're going to do something called casting. So in front of item weight, we're going to put int in parentheses, and then we're going to group together this product, item weight times quantity. So we're taking a double times an int, and we saw that that returns a double. Then we're going to cast it or truncate it into an integer. And what truncating does is it chops off the decimal. It doesn't round it, it just truncate or amputate or chops that decimal off, and then it'll store it as the total weight. So let's pull this back up there and we'll run. Okay, and there's our value, 73, right? It chopped or truncated that decimal off, stored it as an int, so that we could output it to the console. Okay, now while we're here talking about decimal numbers, let's go back to just our weight. Okay, and let's say that the weight was 10.253471. Okay, if I output just that variable the way it is, it's going to print out all of those decimals. If I want to format it so that no matter what those decimals are, it only shows a certain number of decimal places, we can do that with the printf function. So we're going to get rid of that variable. And in the printf function, we're going to create a quotation mark, a %sign, and then a decimal place followed by how many decimal places of accuracy do we want to show. So if I wanted to show 2 decimal places, that would be a 0.2. Okay, then F, and then close the quotation mark. Okay, comma, and what we put after is the variable that we want to format. So we want to format the item weight, and this is going to output that variable rounded to 2 decimal places. So let's go ahead and, or sorry, not rounded, but truncated rather to 2 decimal places. Okay, so there's our 10.25. And if I wanted to show 3 decimal places, I'd change this to a 3. If I wanted to show 4 decimal places, right, I can change it to show 4. Okay. So when we did 2 decimal places, right, it took the third one, and because that was less than 5, it kept it at a 10.25 here. Okay, now for 4 decimal places, 1, 2, 3, 4, it looks at the 5th. Now our 5th decimal place is a 7, which is greater than 5, and notice that it rounded the 4 then up to a 5 in our output. So when you're doing this printf, right, it's not just chopping off that remainder like when we were casting, it just discarded the decimal regardless of what it was. It is actually doing a calculation and rounding your output to that 4th decimal place. Okay, then another thing we can talk about with respect to variables is declaring a variable as final. So a final variable is one that its value cannot be changed. So if I'm going to say that this item weight is, it's declared as a type double, but maybe every single item in my inventory has the same weight. It's always going to weigh 12.5 pounds. It's never going to change to 10.25 pounds. It'll always be 12.5. I can put this keyword final in front of the variable so that it doesn't accidentally get changed later on in my code by somebody who doesn't know that it shouldn't ever change. So I'm going to put that keyword final in the front, and then I'm going to run and see what Java tells me about this reassignment. Oh, got to pull this back up again. There we go. Okay, so we've got an error, one error. It says cannot assign a value to final variable item weight. Because this was declared as final, this reassignment throws a red flag, right? Throws an error. Java will not allow it to compile and run. because it's been declared as final. And things that would be good candidates for final values, final variables, would be like Pennsylvania state sales tax, right? That's a fixed rate, doesn't matter, not going to change. It takes an act of legislation to change that Pennsylvania state sales tax rate. So that would be something that we would have in our code as a final variable. Okay, then one last thing we should probably look at, and those are the chars and booleans. Those, remember we said, are primitive data types. So char, let's say we want the character char for letter A. And we'll just go ahead and assign that to capital A. And then we'll take the char for letter B, and we'll assign that. We'll declare it and assign it on the same line. So we've got A and B. Now let's print. We'll go get rid of print function or format, and we'll do print line here. So we're going to print letter A plus letter B. Okay. When we worked with strings in quotation marks, if we tried to add two string literals, the output would concatenate or join those together, and the answer would be capital A, capital B. So let's take a look and see what happens when we add together capital A and capital B, but they're stored as characters. Okay. Our answer is numeric. It's 131. Okay, and that's interesting. So let's look at why that's happening. So if we copy our print statement here, and we'll paste it twice. Okay, let's start by outputting the numeric value. See if we can get those numeric values to output. Okay, so if we do a system out print letter A, Java is going to print out the letter capital A. Okay, if I want to see that as a value, I'm going to need to add a 0 to it so that it gives me a numeric, a numeric response. So let's go ahead and run that. Okay, and oh, I should have done print line instead of print. So these would be on different lines. Okay, but the 65 that was output, 65 is what we got for the letter A. We put in the character A, but the output when we added 0 was the number 65. The letter B added to a 0 was 66. And then when we add 65 plus 66, that's where this 131 was coming from. Okay, and those values that we're seeing are ASCII values for those characters. Okay, so here's an ASCII chart that I pulled up off of Google. And when we look for capital A on the ASCII chart, there we can see its ASCII value is 65, right? Capital B is an ASCII value of 66. The ones that you need to memorize for your AP exam, you want to know capital A is 65 because they go in alphabetical order, right, from there. So if you can remember that capital A is 65, then you can just count on your fingers or your desk, right? B, C, D, E, F would be 70 because that's 5 away from capital A, which is 65. So you want to know capital A. You also want to know lowercase a. So lowercase a has an ASCII value of 97. And then again, they're in alphabetical order, those lowercase letters. So starting at 97 If you can remember that one, you can count your way to find the ASCII value for H or the ASCII value for T. Okay, those are the only two that you need to know for the AP exam. All the other symbols and such, they're not going to be referenced by character codes on the AP exam, but you will see some problems where they add together like A plus T, or add together capital C, lowercase a, lowercase t, or something like that. And you'll want to be able to recall the ASCII values for those in order to add them on your test questions.